Good morning. Now we're going to take a look at algebraic expressions. This is lesson 4, page 19 in the Swan Math book. And again, we always take a look at what are we learning, why are we learning it, and how do we know we're going to be successful? Well, today we're going to be exploring how to write algebraic expressions. So you're going to be translating from English sentences into mathematical expressions. Why are we learning this? Well, being able to translate from English to algebra is a foundational skill for algebra. It also helps to develop problem-solving and critical thinking skills. And this is how you're going to know you've been successful. You will read the problem, you will identify the operational words and phrases in the problem, and then write the expression. That's where the translating takes place. So first, and you're not going to be able to manipulate these because you're seeing this in the video. But you can actually drag the name of the properties over to the expressions. So what I want you to do is on binder paper or in your math notebook, write down these expressions here. And then I want you to write alongside of it which of these properties you think is represented by the expression. So take about 4 minutes, pause the video here, write down these expressions on paper, and then match them up with the name of the property that you think is indicated in that expression. Okay? Pause the video, come back in 4 minutes, or when you're finished. Okay, so I'm looking at the first one. This says 3 times, parentheses, 2 times c plus 10. And I notice I have 2 operations, multiplication and addition. So I know that there is one property that includes both multiplication and addition, and that is the distributive property. And the distributive property says you're going to multiply 3 by 2 times c and 3 times 10. So now I'm going down to the second property. And the first thing I notice is that my numbers stay the same and in exactly the same place. The numbers do not move. The parentheses are how I group the numbers move. So here I've got 2 plus 3 grouped. Here I have 3 plus 4 grouped. And that is the associative property. Now I'm looking at 25 plus 0 equals 25. I know that any number plus 0 is going to give me that number back again. So that is the identity property of addition. Now I'm looking at 9 times 1 equals 9. Well, I also know that I can multiply any number by 1, and I get that same number back again. So that's the identity property of multiplication. Now I'm looking at 15 times b plus 30. Well, I don't see any parentheses, so it's not associative. I don't have anything on the other side. I don't have an equals on the other side where I can see that the numbers move. But I'm looking again at 15 and 30. And I can pull out a factor of 5. And if I pull out that factor of 5, I would be left with this expression, this equivalent expression. So let me double check and make sure I get this back again. 5 times 3 is 15, and the variable b goes along with the coefficient. So 5 times 3b is going to give you 15b, or 15 times b. 5 times 6 is 30. So looking at this, I realize that the 5 has already been distributed, and I can work backwards to the original expression. So this is an equivalent expression, and it is showing the distributive property. Now I have two property names left, and I have 4, 7, 5. But then on the other side, I have 4, 5, 7. I have the same numbers, but the order changed. These two numbers moved around the addition sign. So if the numbers are able to move around an operation sign, I know that is the commutative property. Nice. Hopefully you had all of these matched up as I did here. If not, go back and fix the ones that you had wrong, or rewind the video and watch this part again. Moving on to problem of the day. I want you to write down these 3 expressions, and then you're going to write these elements that you're going to be looking for under each one. So you're going to set up your paper so it looks just like this part here. Okay, everything that, well, it's not really a circle, everything I've outlined, you're writing down in your paper, on your paper, and then you're going to pull out all of the variables, pull out the terms, pull out the coefficients, and pull out the constants. So write down all 3 expressions and pull out the various elements, and then check back in. So pause the video here for 4 minutes, and then check back in after 4 minutes. Okay, so I need all of my variables. And remember, the variable is the letter that represents an unknown amount. So my variables for this one are y, a, b. My terms are the numbers or variables or coefficients and variables separated by an operation sign. So my terms are 3 times y, 5, a, and 4b. Basically, I'm writing everything down, but I'm leaving out the operation signs. So those are all of my terms. Coefficients. I know the coefficient is the number in front of the variable. So I have a coefficient of 3. I have a coefficient of 4. But I'm looking at this a. I have a variable. There's not a number written in front. But I remember we talked about there's actually a 1. We don't write it, but it's understood that it's there in front of that a. So there's also a coefficient of 1. And now I need a constant. And I know a constant is a number all by itself. So the constant for this expression is 5. Moving on to the next one, my variables are g, w, and d. Terms, again, terms are numbers, variables, or numbers and variables separated by operation signs. So I have 7 times g, 10 w, and 5 times d. Coefficients are the numbers in front of the variables. So I have a 7, I have a 5, and again, I have a variable all by itself, but I know that there's that invisible 1 in front of the w. So I'm going to add 1 as a coefficient. And the constant is 10. Constant is the number all by itself. And variables for this one are m and r. Terms, 15 times m, 17, and 9 times r. Make that look more like a 17. There. Coefficients are 15 and 9. I don't have a variable all by itself, so I only have the 15 and 9. And constant is 17. Okay? Hopefully you got all of those correct. Now we're taking a look at the vocabulary again. And we've already talked about variable, the letter or symbol that represents an unknown value, coefficient, number used to multiply a variable, constant, the number on its own, operator, could be addition, subtraction, multiplication, or division. Evaluate means to find the value of an expression, and simplify, to reduce the number of terms by performing the given operations and combining like terms. When we combine like terms, we're simplifying the expression. So now, input model. And if you have your book in front of you, pencils down. If you're just using a notebook, pencils down. Either way, pencils down. And I'm going to write the expression. Well, I first need to read the problem. And Robin has some golf balls. Peter has twice as many golf balls as Robin. I need to identify operational words and phrases. Robin has some golf balls. Some. I don't know how many that is. So I'm going to have this be my variable, and I'm going to label that G. Peter has twice as many golf balls as Robin. Twice as many. Twice. That means I'm going to multiply by 2. So if I'm going to multiply by 2, he has twice as many golf balls. So, and I know G represents the number of golf balls Robin has. So Peter is going to have 2 times G. And I'm going to write the expression. I'm going to have G plus 2 times G. And that translates what I have here. Some golf balls. Peter has twice as many. Sandra and Leslie are each bringing fruit to a picnic. And remember, I need to read the problem first. Sandra has 3 times the number of bananas, 5 times the number of strawberries, and 4 times the number of peaches as Leslie. And I want to find out how much fruit Sandra is bringing to the picnic. So I need to go through and pick out operational words and phrases. 3 times the number of bananas. 3 times. So I'm going to multiply whatever the number of bananas are by 3. So I'm going to have 3 times B for bananas. She has 5 times the number of strawberries. Well, if I want to know the total amount, I'm going to be adding, and then I'm going to have 5 times the number of strawberries and 4 times the number of peaches plus 4 times P for the number of peaches that Leslie has. And we want to know how much fruit Sandra brought to the picnic. Well, this is what Sandra bought. 3 times the number of bananas, 5 times the number of strawberries, and 4 times the number of peaches as Leslie. Now, let's say I want to know how much fruit they all brought together. I know that this is going to represent Sandra's. So I'm going to put Sandra under this. This represents the amount of fruit that Sandra brought. But I want to know how much they brought all together. Well, does it really tell me how much Leslie brought? Well, they're each bringing fruit to the picnic. And if Sandra brought 3 times, 5 times, and 4 times, that means Leslie's fruit that she brought is going to be some bananas, some strawberries, and some peaches. How much did they bring all together? This is where I'm going to be able to combine like terms. 3 times B plus B. Remember, there's that invisible 1 in front. So all together, I have 4 times B plus 5 times the strawberries. And let me put Leslie here. This is Leslie's amount. Leslie has some strawberries. So if I have 5 times for Sandra and Leslie brought some strawberries, it's going to be 6 times S plus peaches, 4 times the number of peaches, plus what Leslie brought. So I'm going to have 5 times P. And again, I combined my coefficients. There's a coefficient of 1. There's a coefficient of 1. There's a coefficient of 1. And I just added my coefficients to get the total all together. Okay. Now, structured guided practice. And again, we're going to write the expression. We're going to read the problem, identify the operational words and phrases, and write the expression. So Kevin has 7 comic books in a box. 7 comic books, not an unknown amount. I know the number, 7 in a box, and some more comic books on a shelf. Write an expression to represent the number of comic books Kevin has in all. Well, he has 7 on a shelf. That number is not going to change. That's going to be a constant. And some more comic books on a shelf. I don't know how many more he has on a shelf. So I'm going to put C for comic books. And I need to write the expression. And I want the number he has in all. So that tells me I'm going to be adding. So I have 7 plus C, or the number of comic books. You could also write it as C plus 7, the number of comic books plus the 7 he has in the box. And that's it. So now we're going to go to the next structured guided practice. And I want you to pause the video after you read this. And then I want you to find the expression for the number of cards Larry has in all. Okay, pause the video here and then check back in to see how you did. Okay, so I know that Larry and Bill each collected sports cards. I want to know how many Larry has in all. So I'm not going to worry about the amounts that Bill has. So Larry has 5 times the number of baseball cards, 6 times the number of hockey cards, and 7 times the number of football cards. So I'm thinking if I want an expression to represent the number of cards in all, I don't want to use a variable of C because it's different types of cards. So I'm going to have 5 times, I'm going to put B for baseball cards. I want to know in all, so I know I'm going to be adding these together. 6 times the number of hockey cards and 7 times the number of football cards. And now I have an expression that represents the number of cards Larry has in all. And I've translated from English to algebra. Now, you're going to do the 2 final checks for understanding, and then I'm going to have you continue with the student practice, and if you have a homework page, to work on that one also. But pause the video here, complete both final checks for understanding, and then tune back in to see how you did. And if you've got them correct, continue. If you miss something, go back and rewatch the video and then try again. Okay, so pause the video and come back in when you're finished. So now, let's take a look. Bill has 4 stamps, or had 4 stamps. Later that day, his friend gave him some more stamps. What expression could you use to represent all of Bill's stamps? Well, I know that he had 4. That number is not going to change, so that's my constant. Later that day, his friend gave him some more, and he gave him some more stamps. So I'm going to put S to represent the number of the variable for what his friend gave him. And I want an expression to represent all of Bill's stamps. So I know he had 4, and I know that his friend gave him some more stamps. So I have 4 plus S, or you could also write it S plus 4. Okay, now on to the last check for understanding. Alex and Nancy both have a number of pens. Nancy has more pens than Alex. She has 4 times the number of red pens, 2 times the number of purple pens, and 6 times the number of black pens. What expression could you use to represent all of Nancy's pens? Okay, if I want all, I know I'm going to be adding. And now I just want to focus on what Nancy has. So she has 4 times the number of red pens. So I'm going to put 4 times R plus 2 times the number of purple pens, 2 times P, plus 6 times the number of black pens, 6 times B. And I want to represent all of the pens. Well, this represents 4 times the number of red pens. This represents 2 times the number of purple pens. And this represents 6 times the number of black pens. So I have successfully translated from English to algebra. So if you've got these correct, continue on with the student practice and with any other pages that you have to work on. If you did not get this or you're still a little confused, rewind the video and watch it again. And I will talk with you soon.